All right, bioethics for Thursday, last day of April, I think. May is tomorrow for y'all, and that's weird, I'm sure. I'm sure you didn't expect your last month of school to be going this way, but, you know, things are weird. Aliens are weird. The pandemic is weird. All sorts of things are weird, and we just have to live with it. So, we're going to talk about aliens because it's a fun and technically a bioethical topic that bioethicists are interested in, at least a couple of them, at least the weird ones. We're going to talk about like the science of aliens a little bit. We're going to talk about the ethics of the ethical implications of the existence of non-intelligent, intelligent alien life, that sort of stuff. But we're going to start with just some of the science and the crappy old memes. You're welcome. Memes, yes, wow. Okay. The first question we gotta ask about aliens is really the root question of like, do aliens exist? Does extraterrestrial life exist? Extra meaning outside of, terra meaning Earth. So outside of Earth life, does it exist? Are there little green men on Mars? Are there worms on Saturn? Right? Some actual scientists think the answer is probably, which is interesting. Some actual astrophysicists believe it to be the case that there is even intelligent alien civilizations somewhere else in the universe or even in the galaxy. And that's an interesting statement to make, right? It seems weird to make a statement that we have no evidence that aliens exist. Of course, we don't have conclusive evidence that aliens don't exist, so they probably exist. Well, that's a weird statement, right? It'd be like saying, well, there's no evidence that unicorns exist. We don't have conclusive evidence that they don't exist, so they probably exist. And you're like, wait, that's clearly a bad argument. Well, sure, but there's a guy by the name of Drake who has an equation which he claims supports the idea that alien life exists. So let's take a look at this Drake equation. Here it is. Welcome to math. N equals R times Fp times Ne times Fl times Fi times Fc times capital L. Alright. Basically, the number of civilizations in our galaxy with which communication is possible is equal to the average rate of star formation in our galaxy times the fraction of the stars that have planets times the average number of planets that can potentially support life per star that has planets, which is low, right? I mean, like 0.0 something percent, times the fraction of planets that could support life that actually develop life, the fraction times the fraction of planets with life that actually go on to develop intelligent civilization life, times the fraction of civilizations that develop a technology that releases detectable signs of their existence into space, think like radio waves, times the length of time for which such civilizations release detectable signals into space before they blow up their own civilizations with nuclear war, that sort of thing. So, Drake says this is how you calculate whether intelligent life exists, and with the numbers he puts in, it's likely. Let's talk about all the little things. First question is, okay, here's the claim that when you multiply these things together, you get the odds that a civilization exists, that alien life exists. Is that even true? I mean, it's just, he just put it together. Some of it makes sense, right? And in fact, I think it's probably a fair equation, objectively, sort of like a valid equation, maybe not sound, but certainly like a valid equation in that, yeah, okay, the average rate at which planets forms that can support life times the odds that they support life times the like odds that they make an intelligent civilization. Yeah, okay, that all makes sense. The main problem with the Drake equation is this. We can calculate R. All right, we can calculate R. That's real. We can calculate Fp because we know roughly how many stars there are in the galaxy. We know roughly how many have planets. All right. We can even basically calculate Ne, which is the average number of planets that could potentially support life. And you calculate that based on star size and planet size and distance from the star to the planet, basically. You can sort of calculate a habitable zone, an Earth-like zone, around any given star. And so if you have a planet of the right size and theoretically the right composition, around in that like habitable zone around a specific star, that would be any. And basically we can calculate that. It's even better if you can kind of detect if there's water on the planet, that sort of thing. But sure, you can calculate any, let's say that. Here's the problem. FL, the number of planets, or the fraction of planets that can support life that actually develop life. How do you calculate that? You have one data point, and that's Earth, right? So that's kind of a problem, because let's say you can find 100,000, 100,000 planets in the galaxy that can support life. How many actually develop life at some point is one that we know of. And if you use any number other than one, it's a total conjecture, a total estimate, not based on any sort of facts, right? Because there's only evidence that there's life on one planet. There could obviously be life on other planets, but until you know about it, you can't actually plug that into the equation. So you get like one, which makes this whole equation infinitesimally small. Then there's the issue of Fi, the fraction of planets with life that actually go on to develop intelligent life. Well, that's 100%, which is sort of artificial, right? Because if other planets have life, probably not most of them, or certainly not all of them, have intelligent life, right? Let's say there are 100 planets in our galaxy that have life. How likely is it that there's human-level civilization on all of them? Because so far, the planets we know that have life, 100% have civilization. Well, it seems pretty unlikely. Considering most of the Earth's history, there was no civilization. Only like the last maybe 10,000 years, if you want to call it that. Pretty unlikely that, although the number we'd be plugging in here mathematically is 100%, it seems extremely unlikely that if you surveyed 100 planets with life, they would all have civilization. So that number is problematic as well. FC is also problematic because it's 100%. Of the one planet in the universe that we know of that has life, 100% of them release detectable signs of their existence into space. We'd send satellites and rockets and radio waves and a little satellite with all of our pictures and stuff on it to future alien overlords probably, but it's 100%. But it's in reality probably an even smaller fraction. If 100 planets in the galaxy have life and 10 have civilizations, probably not all 10 are space-age civilizations like us. Because, the Earth in 1800 wouldn't have qualified on FC. Earth in 1950 did, but not in 1800. Right? Only the last maybe 100 years, if you're being generous, do we qualify in FC. And finally, the length of time for which such civilizations release detectable signals into space, we have no idea. That's not a real number. Because for us, it's like 100 years. But will we do it for the next 100 years? Probably. Unless we have World War Z and we all die or something, or we get hit by a meteor and all wipes out all technology or some crazy thing. But L, Fi, Fc, and L are all very problematic mathematically. You can plug in Earth, but that's probably not realistic. And you have no way of calculating a realistic number because you have one data point. You can't do good statistics on one data point. You can't do good science on one data point. You can do the first half of the equation, but just not the second half. And so Robert Francis Drake, whatever his name is, who's an astrophysicist, claims that this equation makes it likely, it's proving that it's likely that there's alien life and intelligent alien life out in the universe, especially in our galaxy. But the math just doesn't check out as it is. So some people will use the Drake equation as proof that aliens exist, but take that with a grain of salt, because you can't calculate the last four factors accurately. So math rant over. Is it reasonable? Click this link to hear from Francis Drake and Carl Sagan talk about it, and they'll present a justification opposed to my opposition. Hear both sides, hear it from the horse's mouth, not to call Francis Drake a horse. And we'll end on this a little bit. The Drake equation makes it sound likely, but we still haven't heard from him, right? So if alien life is likely, why haven't we heard from aliens? or seen aliens or seen any evidence of aliens. Well, maybe it's that the real terms for the Drake equation are really small, even though we think they're bigger. That's possible. Assuming the Drake equation is right, that's possible. Is intelligence just extremely unlikely? Like, maybe there's alien life all over the place, but humans are just weird. Right? Maybe there's dinosaurs and dogs and alien space cows all over the place, but human-level intelligence is just not normal. Maybe. Do most civilizations destroy themselves before they travel to space? We almost did. We had 2 world wars before we had a man on the moon, right? I mean, we've been at war the entire time since we've had a man on the moon, like global conflicts, right? So it's possible that maybe civilizations, they develop rocket technology and then use it to kill each other like we did. Or the crazier explanation, the intelligent civilizations out there shut up and we don't. And they shut up because they know something we don't. Like, if you don't shut up, the bad guy will get you, that sort of thing. All of these are possible explanations. The other possible explanation is the Drake equation is wrong. And it's not likely. A possible explanation is we have no way of really having a good way to calculate how likely it is. And so we have no idea if it's likely or not. So we don't, maybe it's presumably unlikely because we haven't heard anything. But we've also only had the technology to be capable of sort of hearing other civilizations for maybe 100 years because of radios, but like practically like 50, 60 years because of high-tech space travel, satellite, big reception dishes on the ground, searching the stars, those sort of things. So personally, I think it's unlikely that there's intelligent life in the galaxy. I think it's more likely that there's any other life in the galaxy, but I still don't know if it's that likely. Fun fact, the Vatican has 2 observatories, one in Arizona and one in Italy. Part of what they do is look for intelligent alien life, and Pope Benedict wrote on, what of aliens who are intelligent? Would they need to be baptized? Does Jesus save them? Did they fall? Like, do they sin? Right? Those sort of questions, which is just kind of neat to think about. And the bioethics of aliens is pretty neat to think about. There's lots of ethical questions to ask, but we'll get into that next time. This time, you don't have to worry about those. All right? You're going to go to OnCampus, and you're going to find your assignment. So let's go find it. We'll go to bioethics. You'll go to your assignments, and you'll hit aliens 1. And you're gonna answer this question: does it matter if aliens exist? I mean, like, if they exist, does it even matter? Who cares, right? And what are the ethical implications for us if they do? What do you think? Right. So, okay, if aliens do exist, how does that affect ethics? How does that affect how ethicists make decisions? How does that affect putting junk into space and those sort of big questions, and nuking asteroids, and how do are we basically nuking our neighbor's front lawn? Is that ethical? Questions like that. So I just want you to think big picture about the ethical implications of if aliens exist and if it even matters if they do. And then we're going to get into some more specific, more fun stuff next week in one of your last weeks of school. Sad day. So that's it for this week. Talk to your parents about aliens and tell them Mr. Fernholz is off his rocker, and that won't be news. See you next week.